this one. Now, let's see if I can actually, yeah, okay. Now what we do, so you needed to know this, right? I don't know if you like to put the 180 in the front and the back. Find the number, the angles, the sum of all the angles in that particular shape. You get the number of sides, subtract 2, and then multiply by 180. For example, triangle has 3 sides, so if you do 3 minus 2 times 180, it's obviously 1 times 180, which is the sum of all the angles in a triangle, or any 3-sided figure. Now, if it was a 4-sided figure, then you would do 4 minus 2 times 180. 4 minus 2 is 2 times 180 gives you 360. Yeah. So I guess you understand it now. So based on that, and minus 2 times 180, let's look at this shape right here. It has 1, 2, 3, 4, 5 sides. Right? It has 5 sides. So if you do 5 minus 2, you're going to get 3. And you're going to multiply that by 180, which you get 540. So the sum of the angles in this shape, right? In this shape, this angle plus this angle plus this angle plus this angle, and that angle equals 180. Now, sorry, 540. Knowing that, right? So, the other thing, the other thing we know is that this angle measures 135. So let's go back a little bit. So in the original figure, right, has 1, 2, 3, 4, 5, 6, 7. It's an octagon. So if you did 8 minus 2 times 180, you get 6 times 180, and 6 times 180 is 1080. Now, in the original octagon, there are 1, 2, 3, 4, 5, 6, 7, 8, 8 angles. So if you divide that by 8, you get 135. So when you know that each angle is 135, right? So you know that this guy is 135 because it's intact, right? There's no line cutting it. This is 135. This one is 35. We also know now, right, that the sum of the angles was 540, right? Of this 1, 2, 3, 4, 5 of a pentagon, right? Of a 5-sided shape was 540. So if we subtract and we get 135 times 3, we get 405. Well, left that 10 minus 5 is 5. 3 minus 0 is 3. We left is 135. So this and this, these two angles, combined measure 135. Now the longest angle, right? Think of a rectangle. The longest diagonal here, it cuts this into 2 equal angles, right? So that is half. Right, so this was 135. If you divide that by 2, you get this is 67.5, and obviously this one was also cut in half, which means it's 67.5, and that's how you get E. I think the key to that question was knowing this. Sorry, 180. Okay, I am going to revisit the. Hang on a second. Let me just take this out. So that's done. Let me take this guy out. Let's work on this one. Now, this one, let me go back, see if I can write. We wanted this angle right here, right? That's the one we know. So we're given a little bit of information. Line CD forms a right angle, right? So you actually wrote 90, 90, 90, 90. So remember what I talked to you about. So as long as I knew this angle over here, I can find the exterior angle. So, and the piece of information that allows me to know what this angle is because we know that it's an equilateral triangle. So the original triangle, EPQ is equilateral, so that means this guy's 60, this guy's 60, right? So, and this, remember we talked about the other day, this exterior angle is the sum of the other two angles that are not adjacent to that. So 60 plus 90 is 150 degrees. Okay. Well, the other way you could have done this, well, 60 and 90 is 150, so you know this is 30, and this is supplemental, so this is also 150. So you could have done it that way as well. Okay. Get rid of that one. This one was interesting. The way that it was okay to do is because we had my quarters, and I don't know how many, so I'll write X, and we had the pennies, I don't know how many, and it was X because the same number of quarters and same number of pennies, so they're both represented. They're both the same value, so we could have used X for both. And we can combine these two, right? And that gives me 26 cents X times X. And that had to equal one of these four, right? Which one would it work? Well, if you try the first one, let's try one by one, 1.17. And you divide 1.17 divided by 26 cents. You move the decimal 2 over, you get 26. Here you get 117. Right? Can 26 go into 117 evenly? Well, it would be times, I would go 4. Well, 5, well, if you go 5, that's 30. Right? Carry 3, 5 times 2 is 10. That's way too much, so 5 doesn't work. So 4, if you go 4, 4 times 6 is 24, carry 2 is 84. So you're going to put 84 over here. 4 on the top, sorry, 84. You're going to subtract, and then to continue this, you would have to add a decimal, right? And see how many. But we can't have point something of a quarter or point something of a penny. So, right, because it has to be a whole quarter and a whole penny. So E, definitely not it. F, again, 0.26, right? If you had that, and what if it was equal to $2.25? Can you use same amount of quarters, same amount of pennies to add up to $2.25? Well, again, you would do the same thing. 2.25, 0.26, so this becomes 26 into 25. If it's 26, it looks like, and maybe an 8. So again, you would get 8, which is 48,204. 1, subtract, you get 21 left over, and to continue, you would add a decimal. And again, you can stop there because you can't have 8 point something of a quarter and 8 point something of a penny. So that's obviously not the right answer as well. So, and you would try and keep going, and eventually you would find out that the one that works is 780. So again, 0.26, right? You move the decimal 2 over, you get 26, and 78 here. Move 780 over here. 26 going to 780, and sorry, 78 3 times. 3 times 6 is 18, carry 1, 78. That's a 0, bring a 0 down, and 26 going to 0, 0 times. So X equals to 30. So that means you had 30 quarters times 25 cents and 30 pennies. Let's see if that works. If you multiply 30 times 25 cents, you get $7.50. And if you minus 30 times 1 penny, you would get 30 pennies. Let me rewrite this a little bit nicer. And if you add them up, you get $7.80. Okay. That's gone. And then this one. Ugh. So I did absolute. So if you haven't done absolute value inequalities, absolute value equations, I'm not too sure how to approach this question. So I'm going to do it that way. It makes it longer, right? It makes it really long, but hopefully you'll understand it. So let's take the first one. So the equation is y equals negative. So y equals negative 3 minus x plus 5. So instead of y, I'm going to replace it with 3. See if it works. So work it out. It's minus 5, right? So it's 5. So I'm going to subtract 5 from each side. I get negative 2. equals negative absolute value of 3 minus x. Now I'm going to divide this by negative 1, and I'm going to divide this by negative 1. If I do that, this becomes a positive. So I actually get the absolute value of 3 minus x without the minus sign in the front. And negative 2 divided by 1 is positive 2. So I want you to think about it for a second, and I'm going to remove the parts that are inside, and I want you to think, when is this ever possible? What can you take the absolute value of and equal to? Well, your two candidates are 2 and negative 2. So the inside part here, as long as it equals to 2 or negative 2, it'll make that equation true. So that's saying that 3 minus x has to equal 2, and 3 minus x has to equal negative 2. Well, if you solve this one-step equation, let's see, if you throw the x on the other side, and you throw the 2 on the other side, it becomes 1, right? And here, if you throw the x on the other side, x becomes positive, and if you throw this minus 2, you do plus 2, x equals 5. So, and again, from here, you can try both numbers. So when x equals 1, let's see if that works. If you plug it in here, right, if you plug the x in, 3 minus 1 is 2, right? And then absolute value of 2 is negative, it's 2, and then with a minus sign it becomes negative 2, and negative 2 plus 5 does give you the 3, so it works. Use a 5 for x. 3 minus 5, again, it's negative 2, absolute value of negative 2 is 2, but because of that minus sign it becomes negative 2, and plus 5 gives you 3. So both of these values work. So this is a potential candidate. Now, I'm going to do 11, just for you to see something. So 11 equals, I'm replacing the y with 11, minus 3 minus x plus 5. So we subtract 5 from each side, just like we did before. This becomes 6. This becomes negative absolute value of 3 minus x. And remember what we did before, we divided by negative 1 and divided by negative 1. Negative divided by negative is a positive, so we're left with this, right, which is nice. And on that side, we are left with negative. So now this becomes very easy, because now I want you to think about this. Let me put that to the side. So we have a negative 6. I want you to think about this without the 3 minus x inside. So what can I put in here, take the absolute value of, and equal negative 6? Nothing, right? Because the absolute value of anything is always a positive number or 0. So there's nothing in the world that I can put in here to make this work. So 11 doesn't work. Now I'm going to do G, only because I want to show you what doesn't work. So 8, again, we do minus 3. Sorry, minus 3. We do minus 5. Minus 5. That goes away. We're left with 3. And then 3 minus x. So we're going to divide this by negative 1. Right? We're going to divide this by negative 1, just like we did before, and divide this by negative 1. So this becomes 3 minus x, absolute value. Right? And 8. And this becomes negative 3. So again, I want you to take a look at this and think about it. What can I put in here, take the absolute value of, and get negative 3? Nothing. That's not going to work. So let's see the one that actually works. The one that actually works, 5. So we get 5 equals 3 minus x plus 5. I think that's the one that works. Subtract 5 from each side. That goes away. This becomes 0. Now we have negative absolute value of 3 minus x. I'm going to divide by negative 1 and divide by negative 1. 0 divided by negative 1, it is 0. And this becomes positive. Now, pull it aside again. When is this ever true? What does this have to equal so that when I take the absolute value, it gives me 0. So this has to equal 0. So this 3 minus x has to equal 0. Well, and the only way that's going to happen is when x equals 3. Right? So when x equals 3, 3 due to 3 minus 3, take the absolute value, is 0. So going back to our original equation, we had 5 equals negative 3 minus x plus 5. So let's see if that works. So here's x equals 3, plug it in here. 3 minus 3 is 0. absolute value of 0 is 0, plus 5 is 5, and that works. So the question is, which is the greatest value of y that makes this possible? Well, the greatest value of y that makes this possible is 5. Okay. Tough question. Tough question. Again, if you haven't seen equations in equality of absolute value, this is definitely something that makes it difficult. And then this one, ugh. So yes, you could have broken it up, and it just happens that it worked for me when I broke this the hexagon into. So I took that hexagon, right, and I broke it into 3 parallelograms, right? But there's something else you could have done, and this is the word that I completely ignored. I just completely. They're similar. So if they're similar, right, their sides are proportionate, right? So there's a scale. So let me draw the one that's inside and the one that's outside. So we know that this is x and this is 2x. So the scale, right, what happened here? It's times 2. So the trick with this, if you know the scale times 2 or times 3 or times 4 or whatever it is to take that scale and square it, because we're talking about area, right? It's to the second power. So take that 2, raise it to the second power, right, the scale, which is 4, and then multiply that by the area of the smaller hexagon, which we knew, and that gives you 12. And that's the answer. I'm going to do another one here. So here is a rectangle. I'm making these numbers up, 3 and 4. And just to prove it here, let's make this 12 and let's make this 9. Okay, so let's do this problem while we know the dimensions. Okay, so look at the height. It's times 3. This is times 3, right? So we increased it by a factor of 3. Now, if you take the area of the small one, it's 12. And if you take the area of the larger one, 9 times 12 is 108. So let me just write this down. The smaller one's 12 and the larger one is 08. Now let me remove some. So let's pretend the question said you don't know the area of the large one. You don't know this. You don't know that. But they tell you that the sides are 3 times longer than the original. Right? So they tell you that to go from here to this side is times 3. And to go from here to here, it's times 3. Right? So the scale, right, multiplier, the increase here, the scale that was used to go to the new one, to the new dimensions, is 3. So if we take that 3 squared, we get 9. And then 9 times the 12, look at that, we get the 108. Yeah, I completely didn't think of that. Okay, so I think these are the questions that I wanted to go over in more detail with you, but here they are anyway.